first video for Unit 2 Mechanics will be the subtopic 2.1 Motion. As with any new unit, there are some key terms and definitions that we need to go over to make sure that we're clear on the terminology that we're using. These ones that we'll be looking at here, you probably have come across them before. We just want to go through them to make sure we're all on the same page and have the same understanding. Now the first key point or key concept is that of distance. Distance has the symbol S. The definition for it is something along these lines. You don't necessarily have to regurgitate this word for word, but it's about indicating how far an object has travelled. So it's about the length. And when we're talking about distance, the other important thing to keep in mind is that it does depend on the path that's travelled or the path taken. And by that I mean if you were to travel, say, let's imagine you're going from the science building down to the flat. If you walked across the road and went down past the library, you'd walk a certain distance. If instead you went across the crossing and down past, I don't know, say heading down the stairs past the St John Pigeon Centre, you'd cover a different distance. So the path that you take can affect the distance that you travel. Now the other important thing to note here, two more things. The first is that distance is a scalar quantity, and I'm hoping you can recall that a scalar quantity only has magnitude. So it's about what the size of the thing is. So if we're talking about the distance that you travel, we might say it's 2 kilometres, 3 metres, whatever it might be. And the units that we use for distance are metres. And the symbol for metres being m, as you well know. So there's all the basics about distance, nothing particularly difficult there. The next quantity then that relates to distance, but in a slightly different way, is displacement. And displacement also uses S, but it has an arrow above the top of it to indicate that it's a vector quantity. We'll come back to that in a second. Just while we're on that, in some resources you might see that the displacement is written S with a squiggle underneath it, or if it's typed it might be a bold S. So different resources will represent vectors in different ways. So just be aware of that when you're looking at different, whether it's worksheets or if you're looking online or in textbooks, whatever it might be, some resources will represent it slightly differently. Now, with displacement, the easiest way to think of it is that it describes the position of an object. So, where an object is located, and if you're talking about where an object is located, you need to state it with respect to some reference point. So if you're thinking about, say, a Cartesian coordinate, if you're looking at a graph or a grid, that given reference point would usually be the origin. If you're looking at a map, it might be a particular location. So again, if we go back to that example, if you're looking at your displacement when you're on the flat with the reference point being the science building, then you'd need to make sure that displacement is stated with reference to the science building. If your displacement was with reference to the flat, then you'd have a different displacement. So it's with respect to a given reference point. Now, the other way to think of that then, that ties into distance, is that it's basically distance in a given direction. So with the idea here of distance in a given direction, it's a little bit, the distance aspect here is slightly different, in that with distance you might say if you're starting off at this point here and you walk a particular path and you end up at this location over here, the distance that you travel would be the length of that squiggly line. Your displacement would be the straight line distance between those 2 points. So the distance here is with between the 2 points, the shortest distance between them. So there's a couple of different ways to think about displacement. As I mentioned, displacement is a vector quantity, and again, hopefully you can recall that a vector has both magnitude and direction. So the difference between scalars and vectors is the fact that a vector has a magnitude and a direction associated with it. And finally, the units would still be the same, so because it's a same quantity effectively as distance, the units will still be in meters. The direction that you might state will vary. The directions might be, say, compass point, so north 45 degrees east, or it might be measured from north, or it might simply just be to the left, to the right, up, down, whatever the direction might be. So there's the first two quantities. The next one then that follows on from distance as well, but in a slightly different way, is that of speed. Now the symbol for speed is v, relating to velocity. We'll get on to velocity in a second. With speed, the important thing here is that it's you need to consider it as a rate of change. So it's a rate of change of distance with respect to time. So, in other words, what you're really looking at here, it's how fast something is travelling. So distance is how far something has travelled, speed is how fast an object is travelling. Now there's a couple of different ways that you can consider speed, whether it's average or instantaneous. We'll look at that in the next video when we relate it to looking at graphical representations of motion. We'll come back to that later. So speed, how fast an object is travelling. It is also a scalar quantity, so because distance is a scalar quantity, speed is likewise a scalar quantity, and the units that it's measured in are meters per second. Now with the representation of meters per second, the text and IB in general will use the index notation form, so ms to the negative 1. An alternative that you might see elsewhere is m/s, so meters per second. In both cases they mean the same thing. Just be familiar with both, be aware that sometimes it'll be represented differently. And the final quantity then is velocity. And velocity again uses v because it's somewhat similar to speed, but it's now a vector, hence the arrow above the top. Velocity is now the rate of change of displacement. So similar idea to speed, it's a rate of change, but now it's a rate of change of displacement with respect to time. And again, a slightly different way of interpreting it. It's still how fast an object is moving, but now in a given direction. So the idea of the vector quantity is related to this idea of it being in a given direction. So as I said, it is a vector quantity, and the units are still the same, being meters per second, and again the direction will be stated according to whatever the scenario is that you're dealing with, whether it's if it's just forwards, backwards, left, right, or it could be a particular direction using compass points, so north or north 30 degrees west, something along those lines. It's just one last thing to make mention of here, just for your own reference. With regards to dealing with vectors, you may need to refer back to subtopic 1.3 on vectors for calculations involving vectors or solutions to problems when you're using vectors. So that's things like adding vectors together, resolving vectors into components. When we do some of the problems that we'll look at with displacement and velocity, that will involve those sorts of ideas, and might be able to go back over them, but if you need a little bit more help, then go back and look at subtopic 1.3 vectors.